All right, here we are back at it again. This is a test review video for Chapter 7. And so we're going to fly through a lot of material. You'll find that I don't finish most of the problems, but I'd like you to get you started on some of them, give you an idea of what it is you need to do to get ready for the test. So first thing has to do with multiplying polynomials. And so sometimes, oh my goodness, sometimes they will look like a binomial, such as x minus 5, being multiplied by 2x to the 6th plus 3x squared plus 15. All right? And so just what you need to know here is there are no shortcuts. You really have to start with x, right, and multiply it by all three of these terms, and then go back with the negative 5 and do the same. In this case, it turns out there aren't any like terms, but in general, there will be like terms that you can combine. Okay, second type of multiplying polynomials would be something like 3b minus 2 to the third power. Now we did learn a shortcut, and if you want to practice that shortcut for the test, you are welcome to do it. But you're also, another way of doing this, takes a little bit more time, is to write the problem as the factor 3b minus 2 three times and simply FOIL these, and then take that trinomial and distribute that, similar to what you did in the first question. Okay, great. Then, after multiplying, we're going to do the reverse, and we're going to factor. And so you're going to have either the sum or difference of cubes. So this is an example of the difference of cubes. And so right away you write two sets of parentheses, and the first one is simply 5x minus 4, and the way I got that was I said that 5x cubed gave me the 125x cubed, and 4 cubed gave me the 64. Okay? Remember the sign pattern is minus plus plus, and then the pattern for the terms here is the first one, we take the first term and square it. The second one, we multiply them together, and the last one, we square the last term. Okay, great. Let's move on to some graphing, and there'll be two types of graphing problems. One, I'll give you factored form of a polynomial, and you have to graph it. Okay, so you have to make sure you understand the difference between a factor that's squared, cubed, and to the first power. Okay, so the first thing you want to do is turn the factors into x-intercepts. Right? So we know that this graph will touch the x-axis at 0, 5, and negative 4. Right? So here's my 0, here's my negative 4, and here's my 5. Then I'm going to go back and I'm going to look at the degree of the polynomial, and I can see that the degree is going to be 6. And so what that means is that the arms, the branches, as they head off the page, are going to go the same direction. Because the leading coefficient is greater than 0, we know that we're going to have a graph that both parts go off the page going up. All right, so let me try to make this look a little bit more accurate. So there we go. So I know when a factor is squared, I'm going to have a bump. When it's cubed, I'm going to have that S shape. It flattens out. And when it's to the first power, I'll start here and I'll go straight through. Right? So at the 0 of negative 4, I go straight through. I curve up and I bump at 0 because the 0 x-intercept is from a factor squared. And then I just want to make sure that when I get to 5, as I get closer, I flatten out. See how I've flattened out there? And it's much different looking than when I went straight through. Okay, so this is an example of looking at an equation, finding the graph. Let's go the other direction, and this time I'm going to have something graphed for you. So let's say it goes like this. It's going to bounce. It's going to flatten out here. Ooh, that's not a very good flattening out. The test will look much better. And then what the heck, let's do one more bounce. All right, okay. And so I got to have numbers here. So let's say this is negative 3, this is 0, and this is 4. Right? So at negative 3, I bounce, so I know that the factor x plus 3 is squared. At 4, I bounce, so at x minus 4, that's squared. And at 0, I have a flattened out s, and so therefore the intercept, the factor at 0, will be to the third power. Because the behavior of the graph, as I go to the right, I'm going up, I know that the leading coefficient is positive. If the graph did something like this, then I know that the leading coefficient would be negative. Make sure you review those things. Okay, here we go. Let's keep going. Let's go into some factoring. So let's go ahead and look at x to the fourth minus 5x squared minus 36. And your job is to factor completely. And so this is the one where we set u equal to x squared, right? And so we rewrite this as u squared minus 5u minus 36, which can factor to u minus 9 and u plus 4, right? And so we're going to put that x squared back in. Right? And this one's super easy, difference of two squares, x plus 3, x minus 3. And then from class today, we talked about the pattern of sum of squares, and the way we factor that is x plus 2i, x minus 2i. All right, great. Let's go ahead and do a quadratic formula that has complex roots. So let's look at x squared plus 6x plus 12 and set that equal to 0, and can't be factored. And so to solve this, we're going to negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 12 all over 2 times 1. Simplifies to negative 6 plus or minus the square root of negative 12 over 2. And then I'm going to skip some steps here and say that you want to get negative 3 plus or minus I root 3. So see if you can't finish that. I took a bunch of jumps there. See if you can't get to that. Okay. You'll also be asked to multiply and divide complex numbers. So let's do one of those, although we practiced this in class and you seem to be pretty good at it. When the denominator is a complex number, the way we get I out of the denominator is we multiply by the conjugate, right? And we know that when we multiply a number by its conjugate, we get the first term squared, 16, plus the second term squared. So 17 is going to be our denominator. And then in the numerator, we simply want to do first, outside, inside, last. And so I'll let you go ahead and see how you get this answer of 10 plus 11i over 17. All right, so make sure you can do a problem like that. All right, then the last types of questions. Am I getting all of them? Oh, I haven't done a long division problem yet. So let's go ahead and save that, and I'll see if I can come up with one for you. Let's go on to rational expressions and equations. Let's see where we are. Oh my goodness, already at 8:15. Okay, so rational expressions, we want to be able to multiply, divide, add, subtract the expressions, and then also to solve the equations. So I'm not going to do one of each because you have that in your problem set to do, but I will go ahead and do a solving one. So this is 5 over x plus 1 plus x over x minus 2 equals 8x minus 7 over x squared minus x minus 2. And your job is to solve. Okay? What I said before is you want to start out by factoring the denominators anywhere you can factor, and chances are when you factor, these factors will look common. They'll look like what you've seen before. In your mind, so this is your mind right here, and you're thinking that when I'm done, I better not get a negative 1 or a 2, because either of those will make the denominator 0, and you can't divide by 0. So just keep that in mind in case there's an extraneous solution. All right, so what we do here is we recognize the common denominator, x minus 2, x plus 1, and we're going to clear that denominator. So I'm going to do x plus 1, x minus 2 here, and x plus 1, x minus 2 here. I'll put it over 1 if that's helpful. When I multiply here, it's the x plus 1s that cancel out, so I have 5 times x minus 2. Here, it's the x minus 2s that cancel out, so I have x times x plus 1. Right? Here, this is great. everything crosses out. So I have 8x minus 7. So here we go. I've got 5x minus 10 plus x squared plus x equals 8x minus 7. We know that to solve a quadratic, we need to bring everything over to the left side, so x squared, and then I'm going to get minus 2x, and then I'm also going to get a minus 3 equal to 0. This one's super easy to factor, x minus 3, x plus 1. Almost done. Answers are negative 1 and positive 3, but then I go back and say, wait a minute, remember this, negative 1 gives me 0 in the denominator right there, so I'm going to cross that out and say x equals 3 is the only solution. Okay? Here we go, last problem. I'm going to do a long division problem quickly. Here's my dividend. I'm going to say that I've got x cubed plus x squared minus 9x minus 9. And I'm going to tell you that 3 is a 0, and your directions are to use long division to find 2 more. Right? So those are your directions. And so here we go. If 3 is a 0, then the long division problem, I use x minus 3 as the divisor. All right? So I multiply that by x squared to get x cubed minus 9x squared. Right? I'm going to go ahead and subtract these, so I get a 10x squared minus 9x. Right? So this time I'm going to multiply by, let's see, 10. Ooh, how did I get a 9x squared? Okay, I got to stop here. I'm trying to do this too quickly. So when I multiply x squared times negative 3, I don't get a minus 9x squared. Oh, I'm so glad I caught that. I get a minus 3x squared, and so I get a 4x squared minus 9x. Much better. So now I'm going to multiply it by a 4x, and I get 4x squared minus 12x. Oh, this is working out great. So when I subtract, I get a 3x minus 9, and so then that's plus 3. 3x minus 9, a remainder of 0. So here's the deal. If I tell you 3 is a 0 and you get something different than 0 for the remainder, you made a mistake like I did there. So don't try to hurry through this. Do this carefully. So now my quotient is x squared plus 4x plus 3. When I factor that, I get this, and those are the factors. Those are not the zeros. The zeros, which is what they asked for, are negative 3 and negative 1. Okay, good. I hope you enjoyed this, and I hope you'll be ready for the test, and good luck. Oh my goodness, 13 minutes.